Hello friends, my name is P. Balamurugan. I am second year ECE student at the Agaraja College of Engineering, Madurai. I am going to discuss about the problems related to negative feedback amplifiers. In this presentation, we are going to see how to solve problems related to negative feedback amplifiers. Let's get into our presentation. The most important thing in solving negative feedback amplifier problems is to find the topology. In negative feedback amplifiers, there are four topologies: voltage series, current shunt, and voltage shunt. These are the four topologies in negative feedback amplifiers. The first and foremost step in solving negative feedback amplifier problem is identifying the topology. If we identify the exact topology of the negative feedback amplifier, it will be more easier for us to do our calculation furthermore, and we can find out the parameters related to them. Let's see about voltage shunt. In this topology, this is nothing but voltage sampling and shunt mixing combination of circuit. How to find the topology? That's what important. Lot of techniques are there, but I follow a easier technique which will be more efficient and effective for us to identify the topology. For voltage shunt, the output voltage node and feedback element connector node should be same. If they are same, we can fix that it should be an voltage sampling one. Then, if feedback element is directly connected to the input, we can find out this is a shunt mixing. If the output voltage node and feedback element connected node are not same, then we can fix that it's a current sampling. If the feedback element is directly connected to the input, then we can fix that it is shunt mixing. For voltage series, the same way that we have done for voltage shunt, but here the feedback element is indirectly connected to the input. How it will be indirectly connected? We will discuss it about later. Then in current series, the output voltage node and feedback element connector node are not same, and at the same time the feedback element is indirectly connected to the input. So uh, we have now discussed four topologies. From this, we can understand that if output voltage node and feedback element connector node are same, we can fix that this is voltage sampling. If they are not same, then we can fix this as current sampling. If feedback element is directly connected to the input, then we can fix that it is shunt mixing. If they are not directly connected to the input, then we can say that it is series mixing. So now we are getting a clear idea about topology. Let's do some exercise. This is a negative feedback amplifier circuit. Let's find out the topology. Just simply we can find out the topology. I will use pointers so that it will be easier for me to represent the problems in an efficient way. Here the output is taken in this node. I am going to tell some shortcuts in my presentation so that it will be easier for us to solve those problems. If the circuit is given, the first and foremost thing you have to find out is where is the feedback element. That's really important. If we fail in that thing, then we are going to lose, we have to lose more marks. Actually, we are going to get 0 if we are not able to find out the feedback element. Here feedback element is R, that is nothing but 82 kilo ohm. How we are saying that? Sorry. Now now let's say about feedback. What is feedback? Feedback is nothing but the part of output is connected to the input. That's it. Here, which element is connected to both output and input? The only element is R is equal to 82K. So this is the feedback element. Now let's find out the topology. The feedback element is connected to this node. The output also taken from this node. So the both the nodes are same. So we can fix that this is a voltage sampling one. Now let's see, this is series or shunt mixing. Let's see, this is the feedback element. This is the input side. Here the feedback element is directly connected to the input. There is no other indirect ways to connect them. So we can fix that this is a shunt mixing. So we can say that the topology is voltage shunt. I hope this is the easiest way to find out the topology. Next circuit. In this circuit, let's see, the output is taken at this node. Okay, before that we have to find out the feedback element. This is the output side, this is the input side. The only element which is connected to both input and output is this 5K ohm resistor. So this is the feedback element. This feedback element is connected to this node, but the output is not taken from this node. So we can fix that this is not voltage, this is current. Why? Because the output voltage is taken from this node, but the feedback element is connected to this node. The nodes are not same. So we can say that this is current sampling. Let's see, this is series or shunt. This is the input side, this is the output side. The feedback element is directly connected to the input side, so we can say that this is shunt mixing. So we can fix that this is current shunt topology. That's it. Now let's see this circuit. In this circuit, where is the feedback element? Here they are taking the output. This is the input side. The only thing common to both of them is this 56K ohm resistor. So this is the feedback element. The output is taken at this node. The feedback element is also connected to this node. So both the nodes are same. So we can say that this is voltage sampling. Now let's see whether it is series or shunt. Now this is the most important thing. The feedback element is connected to the input side, but it's not directly connected, it is indirectly connected. How? The negative, this is the feedback element. Okay, this feedback element is connected here. Now we can say that this is indirectly connected to the input through this transistor. This is indirectly connected. If it is connected to this node, we can say that this is a shunt mixing, but here it is connected here. So this is indirectly connected to the input. It is connected to the input, that's the truth, but it is not directly connected, it is indirectly connected. So we can say that this is series mixing. So for this, the topology is voltage series. Both the nodes are same, so it is voltage. The feedback element is indirectly connected to the input, so we can say that this is series mixing. Next, in this circuit, which is the feedback element? The only thing which is common to output and input is this RE. This is the feedback element. The output is taken at this node. So feedback element and output are not at the same node. So we can say that this is current. And at the same time, the feedback element is not directly connected to the input side. It is indirectly connected to the input side through the transistor. So we can say that this is current series topology. Now we have discussed all four topologies in a clear manner and we have practiced certain problems. If we find out the topology correctly, then we can say that half of the problem is done. This is the step. Now, there are 7 steps to solve a negative feedback amplifier. The step 1 is the most important thing. We have now discussed that one. I hope this that is clear. The step 2 and 3 will be we have to build a circuit, input and output circuit separately for this amplifier, for these amplifiers. This is also an important thing. If we fail, then it will lead to a hectic state. So step 2 and 3 includes building up of circuit, which includes input and output separately. Step 4 will be replacing the active device by its H parameter model. We can replace the transistor with the H parameter so that we can more easily analyze them by using H parameters. But this is an optional one. If we are if you are convenient with this, you can definitely go for this. Step 5 will be find the open loop gain, that is gain without feedback. We have to find the gain of the amplifier without feedback. That's what important. Next, step 6 will be we have to find out the beta. Beta is nothing but feedback gain. So step 5 will be finding the gain of the amplifier. Then step 6 will be find out the gain of the feedback. Then step 7 will be we have to find D. D is nothing but a desensitivity factor. Then AF, RIF, ROF and R dash OF. These are the things that we have to find out. This is the method to solve negative feedback amplifier. Now let's see this problem. This has the topology of the this is the negative, this is the feedback element. The voltage is connected, voltage is measured from this node, so nodes are not same, so we can fix that this is current. It is internally connected to the input side, so we can fix that is series, so we can say that this is current series topology. Next, for this we are building the input and output circuit. This is the circuit. This is current series. So for current sampling, we have to make output current is equal to 0 to make the input circuit. If we make like this, we can end up with this input circuit. For series mixing, make input current is equal to 0 by opening the input loop. If we open this, we will end up with sorting these two elements, which will lead to this circuit. This is the simplified circuit of the given amplifier circuit. Next up, they have represented the circuit by H parameters. This is an easier one because they have just replaced a transistor by means of H parameters. That's it. The voltage V0 is the output voltage that we are going to measure. Vf is the voltage across the feedback. Ri is the input resistance. Ro is the output resistance. RL is the load resistance. Here HFVIB is the current source that we are using in hybrid model. So input current is IB, output current is I0. Next, we are going to see about step 5. We have to find the gain. Before that, I want to share one thing. This is the most important thing, because without this knowledge, we can't solve the problem. This slide. This is the most important slide in this presentation. After finding the topology, we have to do certain calculation. These are the formula list for calculating these parameters for certain amplifier circuits. Here we have taken current series. For that, we have to find GM, which is the gain of the amplifier. For current shunt, we have to find out AI. For voltage shunt, we have to find out RM. For voltage series, we have to find out AV. This is what important is. If we understand these formulas and we memorize these shortcuts, we can easily solve them effectively. And these are the formulas for the certain topologies. If you refer this table, it will be more easier for you to solve any kind of negative feedback amplifier circuit. Now let's continue from where we have left. Yeah, yeah. We have left from here. I will take the pointer. Huh. GM is nothing but transconductance, which is nothing but output current by input voltage, which is nothing but I naught by VI. I naught is equal to IO is equal to minus HFE into IB. How it comes? Because uh, I naught is running in opposite direction, so eventually minus will come. So output current by input current, that is nothing but minus I naught by IB is equal to HFE. That is the current gain. This is what we have seen here, HFE into IB. So output current can be implied, can be implemented as minus HFE into IB. VA is nothing but VS, which is nothing but source voltage. Now we have to find out the source voltage. For that, we are going to use Kirchhoff voltage law. If we use this, Vs is equal to voltage rise is equal to voltage drop. So nothing but IB into RS, next HIE plus RE. IB into RE. That's it. So we can easily cancel IB. So we will end up with this representation. Then the values are given by substituting the exact values. We will be end up with the GM. That is nothing but the open loop transfer gain. That is amplifier gain. Now we are going to do step 6, which is nothing but calculating beta. That is feedback gain. Feedback gain is nothing but Vf by I naught, that is nothing but input to the feedback is divided from Vf, that is output from the feedback. Feedback should give output as voltage and take input as current, that is nothing but IO. Vf is equal to IE into RE, because RE is the feedback element, so IE is the current through the feedback, so we can say that Vf is equal to IE into RE. IE goes IE goes opposite direction to the minus I naught, but equal in magnitude. So we can put IE is equal to minus I naught. So we will end up with minus RE. RE value is given 1.2 kilo ohm. So minus RE is equal to minus 1.2 K. Now we have find out GM and beta. Using them, we can find out D, GMF, AVF, RIF, ROF, and R-OF. These are nothing but desensitivity factor, amplifier gain with feedback, voltage gain with feedback, input resistance, output resistance, and so on. This is the formula which we have seen in that table. D is equal to 1 plus beta GM. We know beta, we know GM, so we can easily substitute and get the answer. GMF is equal to GM by D. This is also formula which we have seen in the table, so we can simply substitute that. Then AVF is nothing but voltage gain with the feedback. So we have to include V0 by Vs is equal to V0 is equal to I0 into RL divided by Vs. We already seen that I naught by Vs is equal to GMF. So AVF is equal to GMF into RL. We have calculated GMF. RL is already given in the circuit. So we can easily substitute and find out the AVF. Next, for input resistance, we have to add all the 3 resistance in that circuit because this is the input region. So these are the input resistors. They are in series connection. So we have to just simply add them. These values are already given. So we can easily find out Ri. With the feedback, we have to simply multiply it with desensitivity factor. So we can get the value of RIF. RO is equal to infinity. This is a, default condition which we have to remember for most of the cases. R naught will be infinity. So ROF is equal to R naught RO into D is equal to that also infinity. R dash OF is equal to ROF parallel to RL. So ROF is ROF parallel to RL. So we will end up at RL. How? ROF is infinity. We already found that. RL is we have assigned some value, that is 2.2k. If we do parallel connection, we will end up with RL. This is a universal thing. If let's imagine two resistors of 5 and 5 ohms and 100 ohms. If they are in parallel, if we take the equivalent resistance, we will be end up with uh, we will be end up with the value which is literally equal to the 5 ohms. So if we take the parallel connection, the output will be the equivalent resistance will be equal to the lowest resistance in that circuit. So we can understand that if we take the parallel connection, we will end up with RL. Now we have uh, now we have calculated all the values, and we have found all the parameters for this circuit. For the same thing, in the same way, we can also do for other three topologies also. For that, we have to memorize the table, so it will be more easier for us to solve them. If you memorize, it will be a cakewalk for you to solve them. So apart from these things, you have to find out the topology. For that, you have to understand these little concept to find those topologies. This is a current shunt connection. This is the equivalent circuit for that. Here also they have found the same way. Here this is a current shunt one. In that table we have to find out the AI, that is the amplifier gain, which is nothing but output current by input current. We can't easily directly find out it because it is involved with two transistors, so we have to do certain things to calculate, because we have to solve them only using known values only. So we have to make sure that the expressions which we are going to use should contain known values. That is what important. If you want to find an unknown value using an expression, and that expression should have known values only. That is the shortcut that you have to keep in your mind. If you don't have any known values, if you have an unknown value to find an unknown value, then you have to make that unknown value into a known value. For that, you can use voltage divider law, Kirchhoff voltage rule, Kirchhoff current rule, whatever shortcut, evidence theorem, Norton's theorem, whatever we can use. That is up to our desire, but we have to clearly understand this concept. That's what important. Here they also have done like the same way that we have done, but the perceptions will change, because of in the previous problem we have found the GM, but here we are finding AI, which is nothing but current gain, that is the overall amplifier gain. And they have did some calculations. That's it. I will try to explain them. AI is equal to minus IC2 divided by IS. We can't find out this directly because these both are unknown values, so we have to make them into known values so that we can represent this equation like this. For this part, we can take it as a AI2, which is nothing but minus HFE, that is the current gain of that amplifier, of that transistor, is equal to minus 50, which is already given. For IC1 by IB1, we can find out that also minus HFE is equal to minus 50. For IC1 by IB1 is equal to 50. For IB1 and IC1, we can't find directly, so but we can use current divider rule. By current divider rule, input current is equal to current flowing through that resistor is equal to input current into the parallel resistors divided by the sum of the resistance. So using that formula, we can find out that ratio. Before that, we have to find out RI2. For that, we have to make an equivalent representation of those resistors. For that, we have done like this. For this only. These are the known values that they have given. By substituting in this formula, we will end up with 3.55K. So we have now find out RI2. Then simply substituting this, we will end up with the minus 0.457. That is the ratio. The one more ratio we have to find out. For that also, we will use the current divider rule. In the same way, we will find out that by simply multiplying all these values, we will be end up with the current gain. In the next step, we have to calculate beta. Beta is nothing but the feedback gain. For that, IF is equal to minus IE RE2 divided by RE plus R dash. We know that by Ohm's law, I is equal to V by R. V is nothing but the VF is nothing but the voltage across the feedback, which is nothing but minus IE into RE2 divided by overall resistance will be RE plus R dash. By simply IE can be replaced with IC, minus IC can be replaced with I naught because they are equal in magnitude but opposite in direction, so we can easily substitute that. So beta will be is equal to IF by I naught because IF by I naught is equal to RE2 divided by RE2 plus R dash is equal to 50 by 50 plus 1.2K. We will be end up with beta is equal to 0.04. Now the same way that we have done in the previous problem, this is not a new thing. This is a already we are familiar with this. These values are having certain formulas, so using those formulas we can find out their respective values. That's it. There is nothing new in this. This is very similar to that. So now we have discussed how to solve the problems related to negative feedback amplifiers. This is the table which is more important. For every negative feedback amplifier problems, we will be given with the circuit only, and they will give some resistors values and H parameters values. Using them only we have to find out all these values. For that, we have to memorize these problems. We have to understand these problems, these formulas. So then only we will be able to solve them. So that's it. This is a voltage shunt circuit. This also easier one, like we have done in the done in those previous problems. This is a voltage series topology circuit. For this also similar way we have to handle, and we have to find out all those values. Actually, this is the end of the presentation. Before I am going to end, I am going to summarize the things which I have discussed. The first and foremost thing in solving negative feedback amplifier is finding the topology. There are 4 topologies are there: voltage series, current shunt, and voltage shunt. If voltage series topology is found out, we have to use you have to find out voltage gain for the amplifier gain. For current series, we have to find out transconductance. For current shunt, we have to find out current gain. For voltage shunt, we have to find out trans resistance. gain. That's it. This is the thing we have to remember. For finding topology, if for voltage sampling, the output node and the feedback element connector node should be same. For current sampling, the output node and feedback element connector node should not be same. For shunt mixing, the feedback element is directly connected to the input side. For series mixing, the feedback element is not directly connected to the input side. If we find out the topology correctly, then we can carry on our next steps. That's it. Uh, by simply understanding these shortcuts, it will be easier for us to solve any kind of negative feedback amplifier problems. Thank you from Balamurugan.